Happy Tuesday evening. You survived the first third. If I remember correctly, we only had one casualty.
Really?
Only one person dropped out.
Yeah.
Oh, yeah.
But that was at the very beginning, so
Does that count?
it does count.
He died of disease.
It means I didn't do my job well enough because only one person dropped on the first day.
My dad didn't raise a quitter.
We're done with vectors. It's not the last we'll see of them, but we're done studying them. So what do we move on to next? Calc 1 is known as differential calculus. Calc 2 is known as integral calculus. They both have one thing in common.
Differentiating integrals? Oh.
Single variant. You only look at one independent variable. Calc 3 is known as multivariate. We're done with a single independent variable. We now consider functions of two or more variables. And if you think about it, function of the form y equals f of x, how many dimensions is that? 2, right? So a two-variate function would be how many dimensions? 3. What about a three-variate? It would be 4 dimensions. So on and so forth. We really only go up to 3-variate. We kind of look at some higher variates in the beginning, and then we kind of just forget about them. So two-variate is 3-dimension. 3-variate would be 4, 5, 6. Right? For most physical applications, how many dimensions are you in? Where's my physics person? She's not here again. She walks in, I'm going to throw something at her. 4 dimensions. You forgot the most important dimension. Time. In physics, time is a dimension. So it's 3 spatial and 1 temporal for most physics applications. How many dimensions is our universe? Tell me that I have a class right now. Yes, I'm already here. How can it take me 7 minutes to get here?
Is this where you bring up the 11-dimensional quantum strings or something?
Don't we just have 3 dimensions? Oh.
10. 9 spatial, 1 temporal. That's down from 26. I don't know if they've reduced it since then. But according to string theory, there has to be 9 spatial dimensions, otherwise the math doesn't work. Which of course raises the question, where are the other 6 dimensions? Theory says they're kind of balled up and unobservable. But you were talking about Bigfoot earlier. I can easily explain Bigfoot. He's a higher dimensional being interacting with that 3-dimensional world. It's very cool. And also fair. We are 3-dimensional beings. There's no way for us to imagine anything above the 3rd dimension. Just like you had a 2-dimensional being, they would have no concept of the 3rd dimension. It just wouldn't exist to them. What does a hypercube look like? We can picture a shadow. The shadow is a cube. Right? Just like the shadow of a cube is a square. So things that seem impossible to us is completely possible if you consider higher dimensions. That is what we're going to start looking at. Starting with a function of two variables. We'll be of the form z equals f of x, y. This function maps each ordered pair x, y in a subset D of the real plane to a unique real number z. So this maps R2 to R. That subset D is called the domain of the function. The domain is no longer an interval. It's a region. The range, just the set of all real numbers z that has at least one ordered pair, x, y in the domain such that f of x, y is z. Now the range is still an interval. Right? So essentially a two-variate function is taking a region in the plane and mapping it to a line. Right? Real numbers, number line. R2 is the plane. So that's what's happening. Level curves. You're already familiar with level curves. Just don't know it yet. Temperature map. Those lines that separate the temperatures are level curves. If you look at a topographical map that shows altitude, the lines that are on that map that separates the altitudes are level curves. Level curve of the function f for the value c is the set of points that satisfy f of x, y equals c. The collection of level curves is called a contour map. So again, if you look at a topographical map, that is a contour map. It has a collection of level curves. Honestly, don't even know why I'm including this next slide, because it's really only used if you're trying to sketch a two-variate function. I will not be doing sketches of two-variate functions. We will be relying on technology for that. If you have a function, z equals f of x, y, with domain that is a subset of R2, vertical trace can be either the set of points that solves the equation f of a y equals z for a given constant x equals a, or solves the equation f of xb equals z for a given constant y equals b. So you have two sets of vertical traces. You have one for your x's and one for your y's. Function of three variables of the form w equals f of x, y, z. This maps each ordered triple x, y, z in a subset w of real space R3 to a unique real number w. W is called the domain of the function. The domain here is a solid. Range is a set of all real numbers w that has at least one ordered triple x, y, z in w, such that f of x, y, z is equal to w. So a three-variate function is taking a solid and mapping it onto a line. Right, then obviously the domain of a four-variate function would be a subset of R4, a hypersolid, and again it would just be mapping that hypersolid onto a line. It's always a line, one-dimensional. Level surfaces. Given a function f of x, y, z and a number c in the range, a level surface of f is defined to be the set of points satisfying f of x, y, z equal to c. Fairly certain there is an equivalent to a contour map for level surfaces. It's just going to be extremely difficult to really comprehend. We're not going to really worry about that. Now what you can do is think of contour map as sort of like the shadow of the three-dimensional object. Then if you collect all the level surfaces, that would kind of act as a shadow for the hyper solid that your function is representing, the hyper region. So to give us kind of a good idea of what it actually looks like, but we'd never be able to get the full picture. Also, we will not be able to plot three-variate functions for obvious reasons. Since we can't even comprehend what the fourth dimension looks like, there's no way we can write a program that would be able to plot a four-dimensional object. It's bad enough trying to plot three-dimensional. You're plotting it on a flat screen. After looking at functions in Calc 1, we looked at their limits. And we saw, of course, the formal definition of a limit, epsilon delta definition. We now examine limits for multivariates. But now the delta is not one-dimensional. The delta has to be two-dimensional if you're looking at two-variate limits. So this is the idea of a delta disk. So a point AB in the plane, a delta disk centered at that point is defined to be an open disk of radius delta centered at AB.
What is an open disk?
So glad you asked, 'cause that's what I was going to ask. What is an open disk, specifically an open region?
It doesn't include the very edge that bounds it.
The boundary. So that is what an open disk is. It's the set of all x, y such that x minus a squared plus y minus b squared is less than delta squared. Right? So it's everything in the circle, just not on the actual boundary of the circle itself. And that is not a good graphic, because that is not open. That's closed. That should be a dashed line. The boundary should be dashed to represent open. I am unfortunately going to have to go over a little bit of my least favorite subject, topology. Oh, topology is awful. The only class to date to give me a migraine. Failed the midterm because the medicine I was on. That wasn't fun.
How do we find delta?
It'll be given. Or you have to find it using stuff that's beyond the scope of this course. So we won't ever worry about it. Cool. First, the idea of interior and boundary points. Now, specifically, we're going to be looking at the topology of R2. Which is a lot better than just general topology. So we say that S is a subset of R2. Now there is a difference between what's written up there and if the subset doesn't have that line under it. Want to take a guess on what the difference would be?
What's a set? Is that a subset?
Subset is a set by definition.
Is it like includes? Is it like when a greater than or less than has underneath it?
Yes, it's the exact same concept. With that line there, we're specifying that S could be all of R2. If I don't include that line, that is exclusive. That means S cannot be all of R2. There has to be at least one point in R2 not in S. So that is also sometimes called a subset or equal to. A point P naught is called an interior point of S. There's a delta disk centered around P naught. That's point P naught is a boundary point of S. If every delta disk centered around P naught contains points both inside of S and outside of it. So what that means is you cannot draw a delta disk small enough such that it doesn't contain points outside of your set. That's what it means to be a boundary point. In layman's terms, interior point is inside, boundary point is on the boundary. All right, so the point -1, would be an interior point. Right. You can draw a delta disk that contains only interior points. 2, 3 would be a boundary point. No matter how small you draw that delta disk, it will always have points both in and out of S. And by the way, this can be extended to any arbitrary set. So you can also extend this to R3. The definitions are the same. But then you can do it for any arbitrary set as well. Now the idea of open and closed sets. Again, let S be a subset of R2. And this can, of course, be extended to anything. We say that S is an open set if every single point of S is an interior point. A set is closed if it contains all of its boundary points. Is this binary? No, it's not. You can have a set that is neither open nor closed.
Contain all of its boundary points. I thought boundary points, the disk was inside and outside the set. So doesn't that mean it's not containing
No.
all of it?
The delta disk contains points in and out. What you're centering at is the boundary point. Here's a set that's neither open nor closed. It contains some of the boundary points, but not all of them. Which means it can't be open because it contains boundary points. Connected sets. Again, we're considering a subset of R2. An open set S is connected if it cannot be represented as the union of two or more disjoint, non-empty open sets. Delta disk is connected. that be connected? So is that a connected set?
No.
You said, what was it?
No.
Why?
I don't know. I just figured I'd take a swing.
Not good enough. You're right. Now explain why.
Is it because you could separate that, I'm just going to call it an infinity symbol, into a left part and a right part?
Lemniscate is the mathematical term.
Okay.
This is the union of two sets. Thus, it's not connected. Generally speaking, if the set crosses itself, it's not connected. A region is an open, connected, non-empty set. Delta disk is a region. That lemniscate is two regions. All that just to define the limit. So this should give you an idea of how terrible limits are in multivariate. Let f be a function of two variables. The limit of f of xy as xy approaches ab is L. Written that way. If for each epsilon greater than 0, there exists a delta greater than 0, such that the absolute value of f of xy minus L is less than epsilon, whenever the square root of x minus a squared plus y minus b squared is less than delta. This is the epsilon delta definition for a two-variate limit. So what this says is that you can make f of x, y arbitrarily close to L by drawing a sufficiently small delta disk around your point. So this is visually what is going on. Here's where the fun is. Oh, I wasn't recording the screen. Oh well. For the limit that was studied in Calc 1, where it was as x approaches some value, let's call it there. I want a cool color. How many ways can we approach A? What are they? From the left and from the right. Where's our point AB? How many ways can we approach it? There's an infinite number of ways to approach that point. We have now lost one of the best ways for determining if a limit exists. Calc 1, limit existed if and only if the two one-sided limits were the same. The idea is the same for multivariate. The limit exists if and only if the limit from every direction exists. The problem is now it's an infinite number. And it gets even worse. Because yes, we could approach from the north, right, south, east, west. We could do the diagonals, right? But we can also do that. Let's do something funky like that. No one ever never said that we had to approach it along a straight line. We can approach it along any curve. So it's not even like there's a countably infinite number of ways to approach. It's uncountably infinite. I like the spiral one the best. So it makes it both nice and not nice. It makes it nice in the sense that if you can find one direction that does not agree with another direction, then you're done. The limit does not exist. However, it is no longer sufficient just to find two directions that match, or 10, or 100, or a Googleplex. They'd have to agree from every single direction, and there's an infinite number of them. So we're going to have two functions, f and g. Say they are defined for all x, y not equal to AB in a neighborhood around AB. Assume that this neighborhood is contained completely inside the domain. Actually, it should be domains of f and g. I have to remember to fix that later. Assume that L and M are real numbers. Our real number, oh dear. It's okay, English is my second language. Numbers such that the limit of f of x, y is L and the limit of g is M. And let C be a constant. Then each of the following statements holds. The limit of a constant is a constant. I do not even bother trying to go through the proofs of these. I think I had to put all of these on different slots too, which is annoying, so I can keep that up there. Limit of x is just a, so you can treat it as a one-dimensional limit as x approaches a. Guess what? Limit of y is just b. So in that sense, they then behave like one-dimensional limits. Limit of a sum is the sum of the limits. Limit of a scalar multiple is the scalar multiple of the limit. Now, these are all the same as Calc 1. product is the product of the limits. Limit of a quotient is the quotient of the limits as long as that bottom limit is not 0.
Or indeterminate form, I assume? Like,
That's something different.
okay.
5 over 0 would not exist. So in this case, we just restrict it to be m can't be 0. Limit of a power, power of the limit. Limit of a radical is the radical of the limit, provided that the limit is non-negative if the index of your radical is even. Right. Removing that restriction is a whole nother course called complex analysis, the calculus of complex valued functions, which I will let you study if you're a math major in your senior year. And even then, you're just brushing the surface. Oh. Those are all the same. Just from Calc 1. With the exception of the two identities. Oh, that's nice. The idea of continuity. Well, what do we think? Is it going to be defined the same way? That's what we're studying in Calc 1. Function is continuous at the point A, B in its domain if the following conditions are satisfied. What's the first condition? Be more specific. F of AB exists. What's the second condition? That's later. The limit exists and is equal to f of AB. So other ways you may see this written. Instead of writing out an ordered pair, we might just write out f of p naught to represent f of AB. Right, in that case, then we could write this. Limit as p approaches p naught. This is particularly useful when you're dealing with more than two variables. Like you're dealing with 3, 4, 5. Then this notation is particularly useful. I did not include it, but but you can extend these definitions to more than 2 variables. So you could do 3 variant. Now you're no longer dealing with a delta disk, you're dealing with a delta ball. Right, but then everything else is the same. 4 variables, you're no longer dealing with a delta ball, you'd be dealing with a delta hyperball. Right, but again, then everything would then be the same from there. Oh, it's just like day 1 of pre-calc. What do we think? How are we going to evaluate that?
Put the values in.
Be more specific.
For each point, it tells you to evaluate. Put the
So we're only dealing with 1 point. So be
Okay.
specific with this
Okay.
1 point.
so just -1 plus 3 times -1 to the 4th.
Replace x with -1, replace y with 3. It will always be in that order. Right? If there's since it's f of x comma y, the first point you ordered pair goes in for x, the second point goes in for y.
When would that matter?
It always matters.
I mean, like, is there a time when if you put them in the wrong order, it will change the answer?
Go ahead and do it here. Put 3 in for x instead of -1.
Oh, okay. I was confused about what you meant by that, then.
It would also matter if I said f of y comma x. Then -1, 3 would be y is -1, x is 3. You have to pay attention to the order. Also, when you're coding, you have to pay attention to the order that you put it in. So it's what, -1 plus 3? So just 2. And tell me, what is f of -4, 2? And what would f of -1, -3 be? What is it?
-4.
I'm an old man, deaf. You have to speak louder. So that was easy. Let's create some contour maps. My dumb self forgot to save the file, so we'll see how well I remember this. Contour plot of the function y minus 2x squared. You then need to enter domains for x and y. Minus 5 to 5. And that is technically all you need. So that's how it looks.
And the axes we're looking at are x and y?
X,
Y.
Y.
Okay, and then the color is for the what we would think of as Z, right?
No.
Uh,
The coloring kind of represents, you could say, like a height,
height. Okay.
sort of.
Okay.
Right, so if you're thinking of this in terms of topographical,
Right. Like towards us, right?
yeah, so what you'd have to do is yeah, it's that.
Okay.
So yeah, think of it like the height. It's the z axis, the z value. But in this case, this kind of gives you an idea. So the darker it gets, the lower it is.
And I understand technically there's no Z in this, right?
But it'd be so it's the height.
Right.
So again, if you think of it like a shadow,
Yes.
it kind of be like the height off of what you're taking the shadow of.
Right.
And this is where I now don't remember all of the options. Let's go here. Now we can get rid of, if you don't like it, frames. I can do that. Gets rid of the frames, and then of course we can set the axes to be true. That kind of gives us more information there. I'm going to get rid of the plot legends for now. I can label them as well. Right, so you see that now you've gained value. So this is telling you the C values. Right, so this is the 0 level curve. -10, C equals -10, C equals -20, so on and so forth. I can also dictate the actual values of C, or how many to use. Right, so let's just start with how many to use. Let's start with 15. Let's say I want to use 15 contours. Now it's going to start to get really cluttered, so let me take out the labels. All right, so that's now using 15 C values, and it's just letting them pick. Or you can choose. of those. And lots of those. So we can also dictate how to shade. So I do none if I just want the level curves. Which is generally speaking what we might stick with. But there's also a whole bunch of oh, I'm doing the wrong thing. That's not what I want. So that'll turn it off. I can choose different colors if I wanted to. And so I can do like red, blue. How many regions are there? 7. I only did 6. That's not the order I thought it would go in. Okay. Or it has several built in. So pastel is one of them. So I can set the color function to be that. Because I actually have a sheet of all these. There's quite a lot of them. Funny enough, you do not have Halloween colors, which is a shame. Of course, they have updated it since then, so they may have added it. Ooh, okay. Favorite drink. Can't start a morning without it. So you get several built in. They're called color gradients. So you can really go to town with it and have a lot of fun and make it look nice. This didn't give us really any specifics, so I'm going to stick with pretty much the default options with one exception. Set the contour shade to be off. I'll just let it pick default contour values and we'll say there's our map. basically just going to be using the same option. I'm just going to copy and paste. And the thing I'm changing is the function. So this one, x squared plus 3y squared. I am going to actually, I think, extend this out a little bit. Maybe go minus 10 to 10 instead. Oh, poo. That didn't really make it look better. So then I will choose contours. Just to get them all to fit. But count how many level curves there are there. How many contour values did I choose?
11.
Where's the 11th? In this case, it's not going to show because it happens to just be a point. It's the origin 0, 0. So I could just get rid of that. Right, that 0 is redundant. Guess I could do fall colors. Make this one look pretty. Okay, that didn't work out. Oh, yeah, duh. Okay, that definitely didn't work out as nicely as I was hoping it would. It's really not that pretty. That's a bummer. Yep, okay. Going back to you disappointed me. Next function was x squared minus 4y squared. And that's how it looks. Okay, so let's extend it out to minus 10 to 10. It actually kind of kept some of them. It's going to be such a pain. let's do those. 0, and then do I want to add in guess it wouldn't be too bad. Try and keep it symmetrical. Oops. Go away. An extra comment here. That's what 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Oh, that's sad. Let's go 60 and 70, just to make it symmetrical. And so again, there's no set way to do it unless I tell you how to choose it. Just have fun with it. I'd say that looks good. And they said math wasn't artistic. I think the next one is actually really boring. It's just negative 4x squared. Pretty sure this is just really boring. Yeah, it is. Boo. Play around with it, have some fun. Domain. We still have all of the same rules for domain. So we have square root of x plus square root of y. What's the rule for square roots?
Has to be non-negative.
What has to be non-negative?
The value under the bracket.
Right. Whatever you're taking the square root of, be careful when you say radical. Does that will apply if it's cube root?
Is the shape not called a radical?
It is a radical, but you can't say what's under the
I
radical.
was going to say like radicand, but I didn't know if that was.
Because if you say under the radical, that could also mean cube root.
Oh, right, yeah.
So it's under the even. What's under an even indexed radical would have to be non-negative, right? Because a cube root, there's no restriction. So that's what I meant by be careful when you say under the radical. So that means that both x and y have to be non-negative. Now remember, domains are sets. Now typically I won't write this, even though technically I should. It's implied that we're dealing with the real plane. So for purposes of our discussion, it is implied that we're only dealing with the real plane, so I'm not going to write it. There are a few ways to write it. You could do this. Right, specifically write out both x and y between 0 and infinity. That's cumbersome. Could write that, right? Both x and y are greater than or equal to 0. And again, that's kind of cumbersome. Standard mathematical practice would be to write that. X comma y greater than or equal to 0. That is short for both x and y have to be non-negative. So there's our domain. What's that region look like?
Quadrant 1.
It's the first quadrant. Just the entire first quadrant. You're missing parts of it though.
Including the positive x and positive y.
Yeah, including the positive x and positive y axes. All right, so if we were to try and sketch it. It'd just be that, and that goes on forever. All right, so that's what that region would look like. Pretty boring region. Oi! I didn't have any more? Oh, I do have, okay, I have another domain coming up. It's a more interesting domain. Okay, I was going to say. Equation of the sphere centered at 10, 10, 4 with radius 9. Bless you. I would say if you cause me to sneeze, it's an automatic F, but I've been sneezing since this weekend, so I'll excuse you. Wouldn't really be fair to accuse you of something that happened over the weekend. Code. The dictator, I don't have to be fair. What is the equation of a circle? Let's start there. General equation of a circle.
X squared plus y squared equals r squared.
That is a special kind of circle. So that wouldn't be the general form.
X minus x naught squared plus y minus y naught squared equals r squared.
Now, you gave me if it's centered at the origin. Extend that. What's the general form of a sphere?
X minus x naught squared plus y minus y naught squared plus z minus z naught squared equals r squared.
So what's the equation of this?
I was going to ask, is it cubed instead, or does it stay squared?
Stay squared. There you go. You could, if you wanted to, expand that out. Then it would just be what? X squared minus 20x plus 100 plus y squared minus 20y plus 100 plus z squared minus 8z plus 16. So that'd be 216. All summed up. You could do that. You could write it then. What's 216 minus 81? So 216 minus 80. 21 minus 8 is 13. So it'd be 136. Yeah, 135. You could also write it in that form. I think that's standard form. I may have gotten those two confused. The top one may be standard, the bottom one may be general. can never remember. Either of those two forms would be acceptable. It'd be nice if your second exam was just a bunch of questions like this. Yeah, it's not going to happen. Second exam covers the start of multiple integration, just to give you a fair warning. I love multiple integration. It's so fun. Domain and range. So we have a square root. So that has to be true, right? 4 minus x squared minus y squared has to be greater than or equal to 0. Which can be written as the set of all xy such that x squared plus y squared is less than or equal to 4. What kind of region is that?
Circle.
Be more specific.
It's a circle of radius 2 centered at the origin.
Open or closed? In this case, it is binary. It's one of them.
Closed.
It's closed.
Yes.
This would be a closed disk centered at 0, 0 of radius 2. I'm going to cheat. No, I can't cheat. Better. That's good enough for government work. Probably actually. That look a little bit better. And then shade that in. Right, so that would be our domain there.
Just to be sure, it's closed because it's less than or equal to. Okay, thank you.
That means that x squared plus y squared can equal 4,
Yes.
which is the boundary of the circle.
Yes.
Right? Less than or equal to means I'm shading inside the circle.
Yes.
Greater than or equal to would mean I'd be shading outside
Right.
of the circle, which would not be as interesting.
It'd be a hole, right?
Essentially be the entire plane with
Right.
a radius 2 hole.
Right.
Range. So if x squared plus y squared is 4, you get the square root of 0. So you just get 8, right? If x squared plus y squared is 0, you get 8 minus the square root of 4, which is 8 minus 2, which is 6. And everything in between. Oops, not infinity. But it does remind me of a good math joke I saw. make sure that the students understood the concept. They asked this question. I'm going to give that as an answer. Don't do that. Limits. So let's evaluate some limits. Well, here we can use the rules. I'm not going to break down every single rule step by step. I was doing 2, limit x, limit y to the 4th minus 7. But ultimately you can break it down to this, which is now sum and product of identities. What was x approaching?
3,
What's y approaching?
2.
Which is that. So again, substitution. Try it first and see what you get. What does that evaluate out to?
Minus 156.
There's your limit, negative 156. All right, so much like with Calc 1, where we don't constantly break down the problem that way, we just immediately go to substitution. That's what I'm going to do. Try substitution first and see what you get. There is one rule you've lost, by the way. You lost L'Hopital's rule. What's the derivative of a multivariate function? A, we haven't discussed it yet. B, it doesn't exist. Instead, it's partials that we look at. So L'Hopital's rule is no longer a thing for multivariate limits. If you can get it down to a single variate, you gain L'Hopital's rule back. So, if we substitute it in, what do you get? Oh, that's nice. That exists. What is it?
Square root 2 pi over 2.
Limits root 2 over 2 pi. Do substitution, what do you get?
A sad face.
Oh, sad face for you, maybe, not for me. What do you get with substitution?
0 over 0.
What is that known as?
An indeterminate form.
Indeterminate, which means we have to do algebra. Well, there's no way to simplify that. That's a bummer. So now the question comes down to, do you think it exists or not? that determines how you tackle this problem. Because if you think it exists, that means you have to actually try and evaluate it. If you don't think it exists, you just have to find 2 ways of approaching the origin that give you different limits.
Professor, we say approaching the origin here because it is looking.
That's why it's going to 0.
Okay, but if it was any other points, we would try and approach. It would be
It would approach it from
that
to
point.
that point,
Okay.
yes. Of course, if it was any other point, this limit would exist.
Yeah.
Let's just approach along an arbitrary line of the form y equals mx. Well, if y approaches 0, x approaches 0. That's why I picked it. I can now write this as a single variate limit x approaching 0. We can factor that denominator as 1 plus m squared times x squared, right? But wouldn't that give you just 1 over 1 plus m squared as long as x is not equal to 0? And if x was 0, it's 0 over 0, so it's undefined. But anywhere else, x squared over x squared is 1. Oh, but we're approaching 0, which means x can't be 0. So we're in the clear. What's that limit?
1 over 1 plus m squared.
Does the limit exist or not?
Provided m exists, it does.
Well, m exists because I said it does.
Oh, okay, then yes.
If I go y equals x, what's the limit?
0.
It's not 1. Slope is 1, I agree. What's the limit?
Half.
What about y equals 2x? Are they the same? Limit does not exist. Specifically because I'm getting the limit in terms of m, that means that the value of the limit depends on the slope of the line. So no 2 lines are going to give you the same limit. So I went a step further. I overachieved. I found an infinite number of ways to approach the origin that give you different values.
I'm having a hard time understanding the jump between what we have here, x squared over x squared plus y squared, and why we are then considering approaching along a line, y equals x.
Because I knew the limit does not exist.
Okay.
So I just said, okay, take the path to the origin along y equals mx.
Right.
This allows me to write as a single variate limit. Replace y with mx.
Okay, I see.
and x would then it would just be strictly x approaching 0.
All right, and then, got it, thank you.
And it completely now depends on the slope
Yes.
of the line chosen, which means we're going to get different limit values. Keep in mind, let's say that gave us a constant, I don't know, 6. Does that mean the limit exists? No. All I did in that case was show that every line will give you 6, not every single possible way to get to the origin. That would not be enough to show that the limit exists. Substitution, what do you get? Nothing. 0 over 0. So again, you have to make a decision. Do you think the limit exists or not? If you think it doesn't, you have to show me 2 ways to approach the origin that give you different limits. If you think it does, you have to evaluate it. Well, we have another powerful tool. Now, tool belt. Square root of x squared plus y squared. Isn't that radius? Let's write this in polar coordinates. So we're doing a change of variable. If we approach the origin, then what does that mean r is doing? So as we approach the origin, what does that mean r is doing? What is r approaching? Go ahead. 0. And this is the limit that we get. What's that limit?
0.
Notice what's not in the limit value. Theta. That means that this limit does not depend on theta, which means it does not depend on how we got to the origin. So the limit exists and the limit is 0.
Is it accurate to say you got there an infinite number of ways?
Yeah, for any possible way that theta can change.
All right.
Right? Because I'm saying this is restricting now to just when r is going to 0.
Yeah.
Right? So that means that no matter what path I'm taking, it's eventually shrinking down to 0. the distance from the origin is going to 0, which means, my point, I'm approaching the origin 0, 0. That's what that means. And the fact that that limit does not depend on theta means that how I do it doesn't matter. Just that it's getting done. Any questions? You're going to have to work with multivariate limits for quite a while to get the hang of it. Because again, you no longer have just two directions. If substitution works, great. If it doesn't work, that's when the fun begins. You try to solve it algebraically if you can get things to cancel, which can happen. If not, you have to see if you can find two paths that don't give you the same value. Try substitution. Polar's not the only substitution to use. You can use any kind of change of variable. And you have to be careful, because like I said in the previous problem, getting that to be a constant not dependent on m does not mean the limit exists. It just means for all of those lines it's the same. Not for every possible path. What we study next is the partial derivative, which is generally an easy concept. It's really not that much different from Calc 1 derivatives. So you have homework due tonight. I believe that is motion in space. Right, so that is homework for tonight. The multivariate homework, that won't be due till the 15th. You'd have a discussion up there. Initial post due October 10th. Replies due October 14th. Replies are not to be up until after initial posts are due. And apparently there's a project that I completely forgot went up last week after I did motion in space. That project is due on Tuesday. I have a question mark there because I am open to changing that. So we'll just see how things go. Again, you can find out what group you're in by going to Canvas, People, Project 2 group.
Links in before you